Let's see what you guys can remember. Do you remember your definitions? What is an element? Can somebody define for me an element?
An element is matter in its smallest state.
An element is matter
Or its simplest state.
in its simplest form. We're not going to use the word state, because when we talk about states, we're talking about what? When we use the word state, what are we referring to? Three states. There are three of them.
My bad. Oh, the three states. Yeah, okay.
The three states of matter. So if you use the word state, normally we're referring to solids, liquids, and gases. But right now, we're not talking about the three states of matter. We're talking about the different kinds or types of matter, which we said in our last session was an element, a compound, and a mixture. Those are the three kinds of matter. So in terms of our definition for an element is the simplest or purest form of matter consisting of only one type of atom. So in order for it to be an element, it has to contain or consist of only one type of atom. That's an element. What about a compound?
A compound is the form of matter where there has to be two different types of matter.
Two different types of matter. Not exactly. Anybody else has any answers?
A compound matter is two or more chemicals connected or bonded together.
Okay, so you're close with it. You're very, very close. We can say that a compound consists of two or more different types of atoms or elements that are chemically bonded together. That's what we said a compound was. It has to have two or more different types of atoms or elements that are chemically bonded together. What is a mixture? What did we say a mixture was? Do y'all remember? What is a mixture?
A mixture is a kind of matter that is made up of two or more elements or compounds joined together.
And how are they joined together? You're like 95% of the way correct. That's Christinique?
They are chemically joined.
They are not chemically joined. They're not chemically joined. How are they joined? How are they combined? What's the other word? What's the opposite of being chemically combined? What's the other word? It begins with a P. Not the right P word. Physically combined. Very good. So when we talk about mixtures consist of two or more different substances that are physically combined. Okay? So compounds and mixtures, just remember, when it comes to a compound, it consists of two or more different elements or different atoms that are chemically combined. Mixtures consist of two or more different atoms or elements that are physically combined. All right? Who can remember now? We would have mentioned this term molecule in our session last week. What is the difference between a compound and a molecule? What is the difference between a compound versus a molecule?
I forgot.
Okay. Okay. I'm going to let you guys think on it for just a few seconds while I type in some of the answers you just gave me. So I'm going to just write them in here. Okay.
I think I have the answer. A molecule is formed when two or more atoms of an element is chemically joined together, and a compound is a type of molecule in which the types of atoms forming the molecule are different from each other.
Okay, so we are on the right track. We are basically right there. So let me just finish this up. A compound consists of two or more different atoms or elements that are chemically combined. And then a mixture consists of two or more different substances that are physically combined. All right, so those were the first three definitions you guys gave me. Now, when it comes to the difference between a compound and a molecule, remember the statement we said last week? All compounds are molecules, but not all molecules are compounds. And it's because in order for something to be a molecule, all you need is two atoms or two elements chemically joined together. That's what a molecule is. Two atoms or two elements chemically joined together. It can be two of the same elements or two of the same atoms, or it can be two different elements or atoms that are chemically joined together. Okay, so with molecules, you can have two of the same. So you can have two oxygens chemically joined together, or you can have two different elements chemically joined together. However, with a compound, the substances that are joining together chemically must be two different things. So you're either going to have two different atoms chemically joining together or two different elements chemically joining together in order for it to be considered a compound. Anyone have any questions on that? So a molecule consists
Can you say what a compound is?
Okay, I can go over right now. A molecule consists of two or more atoms or elements chemically joined together. Whereas a compound has two or more different, the key word here is different, okay? Because both molecules and compounds consist of things that are being chemically joined. But the only comparison we can make, the only difference is in molecules, you can have two of the same things joining together chemically, and it will be a molecule. But with compounds, once you have two of the same atoms or two of the same elements joining together, it's not a compound. Compounds have to consist of two different things chemically joining together.
Yes, ma'am.
Okay? So here's our review of our definitions from last time. Okay? So remember these definitions because we are going to put this to practice, because once you understand the definition for an element, the definition for a compound, what a mixture is, and so on, then you should be able to now identify these different types of matter from various illustration drawings. So let's take a look at this. We're going to practice. Is it an element, a compound, or a mixture? What do you think? I want you guys to do it for yourself first in the chat, and then we're going to do it together as a whole, as a class. A, B, C, or D? A, is it an element? B, sorry, is it an element, compound, or mixture for A, B, C, and D? Identify which one it is. I'll give you 1 minute.
I'm sorry, can you repeat what the question was?
So you need to identify, look at each illustration. Look at, you have 4 of them on the screen. You have A, B, C, and D. You need to tell me if, look at A, tell me if A is an element, compound, or a mixture. Look at B, tell me if B is an element, compound, or a mixture. Look at C, tell me if C is an element, compound, or a mixture. Then look at D, tell me if D is an element, compound, or a mixture. You could type it in the chat. All right, let's look at A, everybody. Let's look at A and see if we can figure out what this is. So anybody want to tell me the answer for A, and then you have to explain why you chose your answer. Is A an element? Is it an element, a compound, or a mixture?
I think A is a compound because you said a compound is 2 different type of mixtures, and there's 2 different type of mixtures or atoms on the screen for A.
Okay, you hear what you said just now? A compound is 2 different types of mixtures. Is that the word you want to use? 2 different type of mixtures?
Oh, 2 different types of elements or substance or atoms.
Okay, very good. So A is definitely a compound. Aaron, you are absolutely correct. This is a compound. And the reason why it's a compound, let's take a look at it. If you were to look at, let's just look at one of these things, okay? Can you all see that there is a large blue circle? Can you all see that? That large blue circle represents one type of atom or one type of element, okay? One type. Do you all see the smaller white circles?
Yes, ma'am.
That is a different type because they look different, right? You got 2 different colors, 2 different sizes. Yeah. Those are 2 completely different types of atoms or elements. And are they physically joined together or are they chemically bonded?
Chemically.
They are chemically bonded. So we have one atom or element in the blue, another atom or element represented by the white. They are chemically bonded. This particular one here is a compound. And if we were to now classify this whole entire illustration, all of these have to be identical for the entire A to be considered a compound. And as we can see, every single one of them, mute your microphone, please. Every single one of them are identical. They're all identical. So this represents a compound. What about B?
B is a
Mixture.
B is a mixture.
Okay, I heard someone say, was that Lewis?
It wasn't me, it was
Somebody else said it before you, Aaron. Yeah.
yes, ma'am.
I tried to figure out who that was just now. I think that was just Shyla. So B is a mixture. Why is it a mixture? And if it's a mixture, you actually can tell me a mixture of what. You can go a little bit further with your classification.
I think it's a mixture because even though there are two elements, they're not connecting, they're not mixed together. I mean, they're not touching each other. So
Okay.
I think it's a mixture.
Okay, I know exactly what you're trying to say. So you have this one here, right? What is this? What does this represent?
It represents an element.
It's an element, or if you didn't say element, what else could you call this?
An atom.
No, they are both individually atoms that are joined together. What did we also remember what we said when we have two or more? Thank you. When we have two or more things, two or more atoms or elements that are chemically bonded, that is also called a molecule. Remember, molecules, you can have the same two atoms joined together. So we can see here, we have a blue atom here, a blue atom here. They're joined together chemically. So that is a molecule, but it can also still be classified as an element. Because as an element, as long as it's the same type of atom, it is still an element. Is that understood?
Yes, ma'am.
Okay, awesome. So we can see.
I have a question.
Yes, go ahead.
If you see how there are two, if one was red and the next one was blue, would it still be considered as one element, or would it be considered as a compound?
You tell me. If I was to color this, oh jeepers, I could be coloring all over the place. Let me see, I can try to color one in red for y'all. So if I was to color one of these in red now,
it would be a compound.
Ooh, what would it be, Aaron? It would be a what now?
A compound.
That would be a compound now. Why would it be a compound now?
Because it's two or more different
because now I have gone and created two different elements now that are chemically joined. Y'all see that?
Yes, ma'am. Yes, ma'am.
Okay, so now let's go back to this B1 now he's working on. He's working on B. So we know that this one here is one type of elements. We know that because we have two of the same type of atoms that are, even though they're joined, we know that elements can have two of the same type of atoms joined, or they can be singly on their own. As long as it's the same type of atom, it is still classified as an element. What is this white one here? How can we classify that?
That is an
molecule or element.
You can use molecule or element, okay? So right now we can just stick with element, but if I ask you to give me another name, you can say molecule. But it is another element. So the white one is an element. The blue one is an element. Are they the same elements?
No, ma'am.
No, ma'am. No, they're not the
ma'am.
same element. So when you have two different elements, are they, look at the blue and look at the white. Are they chemically joined together or are
No,
they
ma'am.
They are
physically?
physically joined together. They are
They are
physically joined
physically
together,
joined together because they are not connected to each other. All
but
right?
they are still in the same
But they are
vicinity.
still in the same container, let's call it. So we have two different elements physically joined together. What description does that fit? Which term?
That fits
Two,
mixture.
that
Mixture.
does fit a mixture. Two different elements that are physically joined together, that's a mixture. What about C?
C is an element because it's matter at its simplest form.
Okay, so we have here just a single, free, on its own element. Very simple. No need to explain that. We could all see why it's an element. It's only one type of atom there. What about D?
It's an element too because it's still the same. It's still one type of atom or element. I mean, still
Okay.
one type of atom. Yeah.
Okay, so D is also an element because we only have one type of atom here as well. Very good. So let me let the rest of the class in. Let's go on and do some more. Now, I want y'all to raise your hand. I'm going to call on y'all to answer these ones. And again, we're just trying to identify whether it's an element, a compound, or a mixture. So if you think you know the answer for A, put your virtual hand up, use your reactions. I'm going to see hands up so that I can call on persons to answer. Let me hear from y'all. Let me see if y'all understanding. And if y'all not understanding, I can always help you guys out. So let's look at the chat. Okay, Paul, let's go for A.
Okay.
You want to try A, Paul?
Okay.
All right, so what's the answer for A? Is it an element, a compound, or a mixture?
I think it's a compound.
You think it's a compound. Let's see if Paul is correct. Do y'all agree with Paul? Is that a compound?
Yes, ma'am.
It is a
Yes, ma'am.
compound.
It's a compound.
It is a compound. And Paul, do you want to tell us why you chose compound? Why did you see it was a compound?
Because it consists of two or more different atoms.
Because we can see, excellent. We can see here that we do have two different atoms or elements that are chemically joined together. Very good. What about B? Who wants to do B for me? I see Trinique.
B is a mixture.
B is a mixture. And why did you say a mixture, Trinique?
B is a mixture because it's two different elements physically combined.
Excellent. We can see here that we have our one element here represented by the little small blue greeny color. Then we have another element here represented by the light blue. We have our two of the same atoms joined, so that is still an element because it's two of the same. The light blue and the darker color blue are not chemically joined together, so they are physically in the same container. So this physical combination of two or more different substances is a mixture. What about C? What about C? C. Aaron?
You want to answer? I think C is a. I think C is a compound.
Okay, let's see if you're correct. Let's look at this one here. What is this representing?
Wait. Can I change my answer?
Go ahead.
It's a mixture because they're not chemically connected.
Okay, so what does the pink color represent? What's this?
An element.
That is an element. And what is this? The yellow and the blue. What are
That's
they?
a compound.
That is a compound. So here we can tell right away we got two different things in here. Two different things that are not chemically joined together. This has to be a mixture. Mixtures consist of two or more different things that are physically combined, not chemically combined. All right, so we can actually say this is a mixture of compounds and elements. What about D? Is that Kamaya? Kamia. Sorry, Kamia.
I think D is a mixture. Yeah, mixture.
You say D is a mixture, Kamia?
Yes, ma'am.
Okay, D is a mixture. Let's see if that is correct. Let's take a look at. Remember, we're gonna just take a look at one of these things, okay? Let's take a look at one. What do y'all see there in that one? What do y'all see?
I see a compound because they are chemically connected.
Okay, we see a compound because what is chemically connected? You have to tell me.
The three different types of atoms.
You see three different types of atoms here. So you see the blue, that's one. You see the yellow, that's another one. And the pink is another one. That's three different types of atoms, all chemically connected. So that particular one that I have a square around, that one is a compound. Now, let's go and see if the rest of the stuff in this, we're going to call this our container. Let's see if the rest of the stuff in this container are identical to this compound. Is this the same thing?
Yes, ma'am.
Is this one the same thing?
Yes, ma'am. Yes, ma'am.
So we don't have any different substances in here to make it a mixture. They are all compounds. So this is just a container full of compounds. Understood?
Yes, ma'am.
Yes, ma'am.
Okay, let's look at E. Who wants to give E a go? Brooklyn.
Is it a mixture?
All right, let's look. Let's see if it's a mixture. Mixture. So in order for it to be a mixture, we need to have what? In order for it to be a mixture, what do we need to have?
Two different types of elements that are not chemically connected. They are physically connected.
We need two different
You need two
substances.
different types.
We need two different things in there that are not joined together chemically. So, do you think that meets the criteria for a mixture?
No, ma'am. It's the
So,
same thing.
they are the same thing. So, when you have all of the atoms that are the same, which one of these types of matter, element, compound, or mixture, does that represent?
An element?
That is an element. Elements, all the same type of atoms. So that is an element. Well, I mean, I feel like E and F are almost like identical. So if E is an element, what does that make F?
Also an element.
Also an element. The only difference is with E has the atoms chemically bonded. So we can also call these a what again?
An element.
Element, or what's the other word we can use when we have atoms chemically bonded like that?
A molecule.
Molecules. And F, we don't have any molecules. Y'all see that?
That's right. Yes.
In F, we only have elements. There's no chemically bonding occurring there. So these are all just elements. So there's no element or molecule there. What about G? What is going on with G? What is that?
Is it a compound?
All right, let's see if it's a compound. Let's take a look. Remember, I always look at one, and then I go and look at the rest. So let's look at it. What do we see happening in that one? I have my square drawn around. What's going on there? What's that?
That is a compound because it's two different mixtures chemically connected.
Listen to what you're saying. Listen to the words you just said. That is a
Oh, mixture.
compound.
That's a mixture.
That's
a mixture.
No, don't second guess yourself right now. You said, I asked a question. My question was, what is this particular one that I have the square? I'm just looking at what the square is drawn around, the red square. All right. Now, you said it is a compound because you have two different mixtures. Be careful.
Two different atoms that are chemically
connected. Now that makes more stats on the ball. We have two different atoms here that are chemically joined. So this is definitely a compound. If you can't see it, let me show it to y'all. We have an atom here represented by the blue. We have another atom here in the pink. Two different atoms chemically joined together. That is a compound.
Yes, ma'am.
All right. Now, look at this one over here. Is this the same thing? That's the same thing. What about this one here?
It's different, but it's still a compound.
It is different. It's different, but it's still a compound because it's still two different atoms, right? So
that's not chemically connected.
Okay, so we can say G consists of two different compounds. Is that correct?
Yes, ma'am.
So when you have two different compounds, what is it? Which one of these things it is?
It's a compound. It's a compound.
You got two different things. Are they chemically combined together or are they physically combined?
Oh, it has to be a mixture because they're not chemically combined.
Exactly. As long as, let me show y'all something. Let me unhighlight these. As long as this compound is not connected to this compound here, that is a mixture because there are two different compounds and they are not chemically joined together. So that is a mixture still. What about H?
I could go.
Yes, go ahead, Brooklyn.
Okay, is it an element?
Okay, tell me why it's an element.
Because it's the same thing.
It's the same thing. So this is all one what? One type of what?
One type of element?
One type. What makes up an element?
Molecule.
Not a molecule. What makes up an element? What's the smallest basic part of an element?
Atoms.
Atoms. So that's all one type of atom. So this is an element. And the last one, I, is that an element, compound, or mixture?
A compound.
It is a compound. Y'all can see why we have one type of atom here in the pink, another one represented by the blue. They are chemically joined together. Two different atoms chemically joined is a compound. And of course, this one here and this one here are exactly the same as it. So this is a compound. Okay.
Yes, ma'am.
All right, so let's clear this all up. I think you guys kind of getting the hang of it. What y'all think?
Yes, ma'am.
Okay.
Yes, ma'am.
Have you guys seen this before in science, or this is the first time y'all seeing this?
Yes,
Yeah, first time.
I haven't done them in depth like this.
Okay, you haven't done them in depth like this, but you've seen similar things, right?
Yes, ma'am.
Okay, good. All right, so we ain't gonna do it. Well, let's try this one. You know why I want to try this one? Because if on your exam they give y'all something like this, they ain't gonna have these nice, pretty colored ones that's so easy to identify. Everything will be in black and white, and you're gonna have to be able to look at it and figure it out. So let's look at this one and see if we can figure these ones out, okay? So let's look at 8. Element, compound, or mixture. Y'all tell me. We should be quick with this one.
Compound.
It is definitely a compound. If you can't see it, let me show y'all. This here is a darker circle than this one here and this one here. I telling y'all, when they print these things out in black and white, you have to look carefully to tell the differences. All right, so you have two different atoms chemically joined. That is a compound. What about B?
Element.
You have all the same atoms. That is an, let me if I can oxygen. That is an element. What about C?
C is a mixture.
Mixture?
Well, let's take a look at it. Let's take a look.
It's a
Compound.
We have compound and mixture. Here are two answers. So here we have one type of atom represented by that dark color one in the circle. So that's one. Then we have another type of atom. This one here, and this one here. They all the same. And then we have a third type of atom here. So here we have three different types of atoms chemically joined together. Now, let's see. So we know that this is a compound. So let's see if this container is all compound. Is this the exact same thing?
Yes,
This
ma'am.
is the exact same thing. Just flip around.
So
Just-
basically,
So it will be a compound.
So this is a compound. Yes.
so basically, it'll have to be like it has to look the same in order to for it to be a compound, and it has to have the exact same amount.
In the container, everything has to look the same. So because we did one of them and we identified this one as a compound, everything else in this container has to look exactly like this one for it to all be considered a compound. If there anything else that's different in here, once we got differences in here, this is no longer just a compound. It is now a mixture of a compound and something else. You understand?
So yes, ma'am. So basically, it can have the same amount, right? It have to have like the exact same amount.
When you say the exact same amount, what you mean?
Like you saw this. Hold on. 1, 2, 3, 4.
I think it's a mixture
Yeah, 4.
because
Which one you talking about? You talking about this one here?
Yes, ma'am. The compound. When you put compound, that's the
Uh-huh.
same amount. It have to have the same amount.
Are you talking about the atoms? Like where I
Yes.
have 1, 2, and 3?
Yes, ma'am. Yes, ma'am.
Yes. You have to have. So how I have number 1, how that atom has to be the same over here. So you have to have one of them in this one and one of them in this one as well. You have to have, I have 1, 2, 3 of the number 2s. I have to have 1, 2, 3 of the number 2s over here as well. If I have a 4th number 2, then this is a different compound altogether. That makes sense?
Yes, ma'am.
Okay. All right, so let's clear all this up. Clear it up. All right, look at D.
That's a mixture.
Why y'all say mixture? How you know that's a mixture? Who tell y'all that's a mixture?
It ain't stuck together like how the compound is.
It
Like,
is.
they're 2 different things, 3 different things.
Okay,
Yeah,
so
and they're physically connected, not chemically.
y'all telling me y'all can see 3 different things, right? So we got
It
one thing
two or
here,
more substances.
we got another substance here, and we have another substance here, and guess what? We got another one here, and we got another one here. So we got all kind of different substances. We got this one here. This is an element. This one here is another element. This one is another element, and this one here is a compound. So in this particular diagram, we have a variety of different substances. We have a variety of different elements and compounds. So that would be considered
A mixture.
a mixture. All
The
right.
next one is an element.
Why is it an element?
Because
There's
it's
one type of
2
atom.
the same things.
Because you only
Like-
have one type of atom.
Yeah,
Only one type of atom, so it is definitely an element. And what about the last one?
Compound.
That's a compound.
Compound.
It's a compound. They are 2 different elements or 2 different atoms chemically joined, and they are all the
Yes, ma'am.
same. This is a compound for sure. Okay.
Yes, ma'am.
All So let's go on. All right, we'll come back to the Kahoot game because I want to go through some stuff now. All right, so now that you guys know the difference between the three kinds of matter, element, compounds, and mixtures, we are going to talk about each one of these individually, starting with the elements. So all of the elements that have been discovered in science thus far are placed on a table or a chart that we call the periodic table of elements. So it's a table or a chart that organizes all of the elements that we study in chemistry, which is a branch of science. All right. So here are all of our different elements that we study. Renayo, you have a question?
Yes, ma'am. My teacher said we have to know about the noble gases. Would you be able to tell me which side that would be on, or which element, or whatever it is, please?
Okay, sure. We will actually, I don't want to jump straight to that, right? I don't want to talk about that too much. I will tell you that the noble gases. Let me do this part first, and I'll come back to the noble gases, okay?
Yes, ma'am.
All right. So when we start off studying the periodic table, the first thing we have to do is we have to understand we call the periodic block. The periodic block. And if you look at my screen, this is a periodic block. So this here is what we call the periodic block. And this block actually gives us some very important information about each of the elements in the periodic table. All right. So let's go on. Let's talk about some of this information. So here is the element what? What element is this?
Oxygen.
This is oxygen. And this is the element, what the element block for oxygen looks like. And if we were to now dissect this element block and look at the different components, we can see that
it has 3 parts.
It has, well, 4 main components to it. We have the atomic number,
the elements,
we have the element symbol, element name, the element symbol, and the atomic mass or atomic weight. And each of these things has a meaning. They have an importance to the element. So this atomic number, this atomic number, very important. This atomic number tells us how many protons there are in the atom of oxygen. And where do we find protons, by the way? Where are they found? Which
in
part
the
of the
middle
atom?
of the
They are found with the nucleus.
And inside of the nucleus. So we're going to use, please remember to use the proper term. So yes, it is the center, but we call it the nucleus. Okay? So the protons are found in the nucleus of the atom. So this atomic number tells us how many protons can we find in an atom of the particular element. So for oxygen, because we have an atomic number of 8, this tells us there are 8 protons in the nucleus of an oxygen atom. Everybody understand that so far?
Yes, ma'am.
All right, because this atomic number also tells us a second piece of information. The second piece of information we get from the atomic number is how many electrons now there are inside of an atom of the element. So in essence, the number of protons is going to be the same as the number of electrons. And where do we find the electrons?
They are found on the orbit. They are
on the energy shell?
On the orbit, on the orbital shell. On the orbital shell.
Or the proton cloud.
Or the element.
Or the element cloud.
So
the electron
cloud. The electron cloud. All right, so the atomic number tells us the number of protons in the atom, and it also tells us the number of electrons in that atom. The element name, very simple. It is simply a common name given to the element. The element symbol is a 1 or 2-letter abbreviation for the element. So you will notice on the periodic table, some elements just have 1 capital letter to represent their element symbol. Some elements have 2 letters. For example, chlorine has 2 letters, a capital C and a small l. So whenever an element has 2 letters to represent its symbol, the first letter will be capitalized and the second letter will be a small letter. So if y'all see, for example, if y'all see this written, this does not represent 2 elements. Because we have a capital letter and a small letter, this is all 1 element, and this is calcium. Everybody understand that?
Yes, ma'am.
Okay. All right. Lastly, we have the atomic mass, which is also called the atomic weight. And this atomic mass or atomic weight, which is a number represented at the bottom here, tells us the number of protons and neutrons there are in the nucleus of an atom. Remember, we talked about how all of the weight of an atom is found in the nucleus because it's the protons and the neutrons that are carrying the weight. And so this weight called the atomic weight is made up of the protons and the neutrons. Let me see if y'all understanding this. So let's test this out. This is our summary of what we just discussed. The atomic number is the number of protons in an element, which is also equal to the number of electrons. The atomic mass is the number of protons plus the number of neutrons in an element. So let me ask y'all this, students. We know how to find just the protons, right? What do we look at to find the protons? What do we need to know? What do we need to know to find how many protons there are in an element?
Protons have a positive charge.
No, look at the information that we have here. Okay, so looking at the information we have, once we know the atomic number, this tells us how much protons there are. We can also find the number of electrons. How can we find the number of electrons?
The atomic number as well.
The atomic number as well. Is there a way, think about it, is there a way that we can find the number of neutrons by itself?
No, ma'am.
Yes, ma'am.
No, ma'am.
Okay, let's think about it. If the atomic weight, if this number here tells us the number of protons, I'm going to write it right here. If this tells us the number of protons plus the number of neutrons, right? And the atomic number tells us the protons. Let's just stick with protons, even though we know it's the electrons too. Can anybody think of some type of mathematical statement or whatever we can do to find just the neutrons?
Just subtract.
Just subtract. What are we subtracting?
15 and 8.
Atomic number and the atomic weight.
If you were to subtract the atomic number from the atomic mass, you will get just the number of neutrons. Because if you subtract the number of protons, which is the 8, away from the number of protons and neutrons, you will be left with just the number of neutrons. Y'all saw that, right?
Yes, ma'am.
Atomic mass, atomic number tells us number of protons, which is the same as the electrons. Atomic mass tells us number of protons plus neutrons. How do we find just the number of neutrons? You subtract the atomic mass from the atomic number and it tells you how many neutrons there are only. All right. Can y'all fill this out for me quickly? Let's go. Let's see if y'all... What is a 6? What does that 6 represent?
Atomic number.
Atomic number.
All right, atomic number. I'm gonna abbreviate. What is a C?
Element. This element
symbol.
symbol.
Element symbol. What is the carbon?
Element name.
Element name.
Name. And the 12?
Atomic mass.
Atomic mass.
Atomic mass or atomic weight, whichever one you want to use. Very good. Awesome. Now, what I want you guys to understand, because we can look at this element block information and we could do so much with this. For example, what is the name of this element?
Chlorine.
This is chlorine. So I can ask you so many things about this. Suppose I ask you, students, what is the atomic mass of chlorine? What would y'all tell me?
35.4527.
35.4527. Now we can look at this, and if y'all ain't comfortable with dealing with so much numbers like this, if you are good with math, you can round it off. So how do you round? Well, you look at the very first number after the decimal place, which is the 4. Okay? And if this number here is 5 or more, then this 35 goes up to the next whole number, which is 36. So
And
let me
then
say,
the digits is 0, right?
pardon me?
And the rest of the digits is 0, right?
It's 0,
After-
but you don't have to write them. So
Oh.
if this number here is a 5 or higher, this number here changes to a 36. If this number is a 4 or lower, which it is, then that number remains a 35. Like I said, you can choose to work with the decimals if y'all want. I personally don't like working with decimals, so I like to round using my rounding rules. So I like to work with just 35. Because this number here is lower than 5, I have to round, I have to keep this as a 35. I can't round it up.
So when you round, you have to
Now,
So when you are rounding, either you're going to round up to the next whole number, or this number is going to stay the
round
same.
down to the same number.
Round down to the same number. So this
Will
can
it still
either,
give you the same number of points if you round?
you can round,
Yes.
yeah, you can round. So as long as you're rounding the right way now, because let me tell you something. If you go and you say, oh, I'm going to round this 35.4, oh, this is going to be 36. That's not correct, because 36 is not the answer. The right way to round this would be 35. That's why I say if you are comfortable with math and you can round it, then sure. Okay, so this is actually going to be, I'm going to work with 35 for this. So we said the atomic mass is 35. Very good. What's the atomic number?
17.
It is 17. That's the atomic number. How many electrons are there in chlorine? In an atom of
17.
chlorine?
17.
17. How did y'all get that?
Because
By
the
looking at
atomic
The
the
number of protons and electrons are the same.
Because we get it from the atomic number, because we know that atomic number tells us how many protons there are, which is going to be the same as how many electrons there are. Very, very good. Can anybody tell me how many neutrons there would be?
18.
Y'all didn't do this problem, and y'all didn't work this out before I ask the question.
Yes, Mom.
So it is going to be 18. So 35. How did y'all do it? Y'all tell me.
I just left the
35
decimal.
by 17.
35 take away 17, because remember, you're taking away the atomic mass, subtract the atomic number, tells us the number of neutrons. So we have 35 take away 17, and your answer is
Equals
18
18.
neutrons. Okay,
Yes, ma'am.
let's try another one before we go. What is this element here?
Magnesium.
Magnesium.
Magnesium. What is the symbol for magnesium?
Mg.
Lowercase g.
Capital M, lowercase g. Very good. What is the number of protons for magnesium?
12.
12. What is the number of neutrons for magnesium?
12.
12.
12, because you're taking away, if you're going to round, remember I said if you want to use the rounding method, this 24.305 will just be 24. Okay? So
That's right.
to find neutrons, take away 12 from 24, you're left with 12. So there are 12 neutrons. How many electrons?
12.
12.
There are 12 electrons as well. Very good. So everything for magnesium is 12. 12 protons, 12 electrons, 12 neutrons. And of course, you can use this information, students, to then go ahead and even draw these atoms. Because once y'all know from the element block, once you get this information about how many protons, neutrons, and electrons there are, you can use this information to go and draw your atoms now. All right? So we can do one more. Let me just do one more quick. Ladder drawing. Ooh, it's a nice one.
We still doing the quiz.
We can do it next time. I can give y'all a quiz on this and the element molecule, element mixtures and compound stuff next time on Thursday. So let's take a look at this. What is this element name?
Gold.
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 What is the symbol for gold?
AU.
Capital A, lowercase u.
Capital A, lowercase u. Keep in mind, notice how this symbol looks completely different from the name gold. The symbol is not a G. It's not a GO. It's a capital A and a U. That's the symbol for gold. What is the atomic mass of gold?
196.
196.
196. If y'all giving me a whole number like that, y'all gonna need to round. If y'all give me the whole number. So what do we round? 196.9672.
197.
197. Because I told y'all you have to look at the first number after the decimal place. And if that number is 5 or greater, this number here in green has to go up to the next whole number. If it's a 4 or less, 196 would stay the same.
So the answer is 118.
The answer is 197. That's our atomic
Oh,
number.
I subtracting.
I know you subtracting. So 197 is our atomic weight. So 118 is what, Brooklyn? What you was calculating just now?
197 take away 79.
And that gave you 118, which is the what? What is that you're finding out?
Electron?
Not electrons.
Number of neutrons.
The number of neutrons. Number of neutrons would be 197 take away 79, which is 118, which is our number of neutrons. All right. What about the protons? How many protons are there?
79.
79. And electrons?
79.
79.